Look closely at a simple gold ring. The atoms of gold inside that metal were not forged in the Earth's crust, nor were they made inside a standard star like our Sun. Creating heavy elements like gold and platinum requires the violent energy of a kilonova, the collision of two ultra-dense neutron stars. Neutron stars are city-sized atomic nuclei with a rigid crust, electron-fluid atmosphere, and superfluid core. Upon collision, intense gravity shreds this crust. The scattered debris triggers a chain reaction where atomic nuclei absorb free neutrons, forging the heaviest elements in the universe. We can measure these events from Earth. Gravitational wave observatories like LIGO have detected the specific ripples in spacetime generated by neutron stars merging in our local universe. Local kilonovas provide an observable mechanism for the destruction of stars, the birth of black holes, and the creation of heavy matter. While local astrophysics is well documented, the standard model for the birth of the entire universe is currently struggling to match entirely new observations. The James Webb Space Telescope is finding massive, organized spiral galaxies that existed just 600 million years after the Big Bang. Current models suggest it should have taken billions of years for galaxies of this scale to form. Maps of the cosmic microwave background reveal another issue. Instead of a smooth, uniform plasma, we see massive temperature alignments, dipoles and quadrupoles that mirror the structure of organized standing waves. Additionally, when astronomers map the rotation of spiral galaxies, they find a distinct asymmetry in their spin directions, suggesting an underlying cosmic order. These anomalies suggest that our model of the early universe is missing a critical piece of the puzzle, a puzzle that may be solved by the same kilonova blueprint that forged the gold on Earth. The Big Bang kilonova hypothesis addresses these mysteries through the lens of fractal geometry. This approach relies on scale invariance, the observation that physical laws and geometric patterns repeat themselves identically across every scale of existence. Applying scale invariance to our universe suggests the Big Bang was a macro-scale kilonova, occurring within a much larger parent dimension called the superverse. Under this model, our own universe functions simply as a mechanical byproduct of a massive astrophysical event in a higher dimension. Imagine the kilonova blueprint scaled up to the macro level. Two superneutron stars begin to orbit one another within the superverse. As they spiral inward at near-light speeds, colossal gravitational shear shreds their outer supercrusts. The immense crushing weight of these two superstars causes their cores to entirely collapse, forming a singular, violently rotating super black hole. Gravitational torsion prevents the matter from reaching infinite density. Instead, it tears space-time, opening an entrapped wormhole to a white hole on the opposite side. Intense pressure then causes this white hole to inflate outward like a balloon, creating a massive, expanding spherical manifold. This rapid inflation of matter and energy is what we currently observe and label as our Big Bang. Mapping the debris from this supercollision helps account for the anomalies in our early universe. As the supercrust shattered, heavy atomic nuclei from the parent universe fell into our manifold. These fragments provided the supermassive black hole seeds required to form Webb's massive early galaxies. This comparison aligns the fluid quantum vortices of a rotating core with the temperature maps of the cosmic microwave background. The spin of the collapsing supercore transferred through the wormhole, imprinting these exact standing wave patterns onto our early plasma. The forensic debris signature of a superkilonova provides a structural framework that explains the anomalies present in the cosmic microwave background. While we await further data from deep space telescopes to test these specific predictions, this hypothesis offers a different cosmic perspective. It presents our universe as a child, born from the destruction of a parent superverse. The logic of scale invariance suggests that the black holes within our galaxies may be tearing open wormholes and seeding new subuniverses right now. This suggests a cosmos defined by an infinite fractal chain of death and rebirth. Within this model, the destruction of stars in one dimension literally seeds the birth of time, space, and matter in the next.